Okay, hello everyone. Welcome to this video. In today's video, we'll be looking after client-server model, peer-to-peer network model, thick client, thin client, and of course cloud computing. So these are the topics we'll be covering in this video. So this would not be a far-fetched claim if I claim the fact that 90% of the systems in the internet run in a client-server architecture or a model. I'll give you an example. So basically, there are clients, right? Lots of clients that demand services from a server. This is a client-to-server architecture. I'll give an example of a macro scale and a micro scale as well. So example, these are our client's computer, this is internet, and this is a server network. I'll give you an example of YouTube. So we as in client side open the YouTube. We're basically accessing the YouTube server, which might be in your own country sometimes, or for the ease of explanation, let's say it's in Silicon Valley in California. How do we access that? Well, we press the link www.youtube.com and you click on a video. Whenever you click on a video, you're basically requesting an access to that content. And the server side permits the access and you get a chance or you get to view the video. Right? This is a basic example of client-server model. Now, this is an expansive idea of the client-server model. Now, if I had to reduce it into a very small form, an example could be your own computer lab. Most of the schools these days use something called vCloud or something like that. So lots of computer labs, they have monitors, a small box thing attached behind the monitors, a keyboard and a mouse. We barely see any CPUs. And all these monitors, let's say 20 of them, are connected to a central server. These servers have around, let's say, for our example, 3000 plus GB of storage. They have high-end processors, and all of these computers access these services. Now, what are services in our case? Well, basically processing power, right? And storage, etc. So, if I had to purchase a very low-end computer, that would have costed me $300 each computer. And if I have 20 of those, that would be $6,000, right? But with this setup, I could just buy a high-end graphics card for, let's say, $500. I could get hard disks in bulk, let's say 3 hard disks for $300, and the monitors and all would cost, let's say, $1,300. Now I have reduced the cost from $6,000 to basically $2,600. And remember, I can always expand this. This I cannot. Also, I cannot have a central control or center authority over if I had CPUs in a network. But if I have all these computers connected to a central network, I could have students in check, I could view and block websites, etc., etc. So this is basically client-server model architecture. Now, it uses a separate dedicated servers. Yes, so clients or computers will be connected to the server. Users are able to access most of the files which are stored on dedicated servers. That completely makes sense. The server dictates which users are able to access which files. So level of access. For instance, you have a user account, and for each user account, a level of access is dictated or stated. So your A-level coordinators or IB coordinator, whenever they log into their account, they can view 90% of the files, or let's say 100% of the files. But you as a student can only view 50% of the files because you do not have access to all the documents. This can be created using a client-server architecture. You could expand the network as much as you want. So emails and all could be done inside the network. So internet versus intranet. Intranet is a private internet. Internet is basically network, so whenever you have a private network, it's called intranet. But at the same time, there are some disadvantages. So if something error has occurred in the server side itself, it affects the whole network. The client server network can be bottlenecked if there are way too many requests from the client side. So that's another thing. And so a server is basically responsible for central storage management of data files, allowing users to share information, remote storage devices, right? Now if I had to go into peer-to-peer network, so peer-to-peer network is basically, if I had to give an example, it's uTorrent. So client server architecture is a centralized system. I will be using this word frequently, so I would love to describe it in detail. So centralized system is something where a central authority, CENTRALIZAD, has control over all other aspects within a network. A decentralized system right is a type of network where there is no central authority. So we are decentralizing the network. So in peer-to-peer network, all the nodes, or basically clients, are connected to each other nodes, right? So and these, all the networks have few parts of a file, let's say. So there is 1 GB of file, and it's been divided into all the nodes. So 1 2 3 4 5 6 7 8 9 10. These nodes are connected to all the other nodes since we don't have a central system. And 0.1 GB, 0.1 GB, 0.2 GB, 0.5 GB, 0.5 GB, 0.1 GB, 0.1 GB, 0.1 GB, 0.1 GB. So, and since they are basically connected to all the nodes, they can share the file. This is how a peer-to-peer network works. Example: BitTorrent, uTorrent, the Pirate Bay. This is why you can never put websites like torrent websites down, because there is no central authority. Whom are you going to bring down? Every user that's connected to the network has an access to the file, and you can't put everyone down. You can't bring everyone down. Right. So the provision of services to all other network users. So every devices will be looked after, and although my example mentioned that every node has an access to the file, but that's not the case. Since our example was limited to only 10 users, I had to make sure that it happens, and they can basically access data from one node to another, and peers to both suppliers and consumers. So a client could be both supplier and consumer at the same time. This is why seeders and leeches concepts, right? I'll come to that in detail. And every peers can participate equally on the network. Peers, nodes, clients, basically same thing, right? So this is it about the peer-to-peer network. Now let's start with thick client and thin client. So from this thing, you just need to know the difference between. So thick client and thin client. Let me just take a screenshot of this, and I'll paste it in the whiteboard. Right. So thick clients are basically more robust. So I'll come, right? So thick client is a type of network or device which can carry out lots of processing on its own, right? And it is not just limited to devices. It's a thick client system could be a software, it could be a network architecture, it could be a device itself as well. So imagine a computer. A computer has its own RAM. You would be limited if it was not connected to the server, meaning internet, but there's lots of things you could do within the computer itself. You could play offline games. you could work on Word files, you could code, you could edit videos, right? So device can carry out processing even when not connected to the server. So a Windows PC or Mac OS or Linux is an example of thick client, whereas Chrome, I forgot the name. There was this laptop that used to run on Chrome OS, Chromebook, my bad. So a Chromebook would be an example of thin client. It requires access to the central system to power it. Clients have more control, exactly. So imagine, you can take an example of Word itself. Whenever Word was truly offline, we could store everything in our desktop, but right now it has been heavily dependent on the wave and cloud, so we need to buy storage, etc., etc. So as a clients, we don't have much control over the Word software suite. But at the same time, it's less secure in a sense that if the client is not smart enough, they could completely risk the security of their data. They also should be careful enough to update, save, etc. Such as in Docs, you don't have to worry about saving your data. It automatically saves. Well, if you tinker with the settings and all, you could do that in Word as well. At the same time, data integrity issues. Sometimes there is inconsistencies, as clients might access the same data. So if I give my cousin to use my laptop, they could overwrite my file, etc., etc. in our context or example. Thin client, well, basically it's less expensive to expand. So basically Chromebooks are usually cheaper. Well, because the hardware resources and requirements are very less, and it's linked to a central server. So every new update is done centrally. And most of the services and protection is provided by the server itself, so it's comparatively more secure. If the person using the device is I don't know, is not much efficient or proficient, or is not tech savvy, let's say. High reliance on server. Okay, so if the Chromebook is not connected to the internet, well, we can't do much. Despite the cheaper hardware, the startup costs are generally higher than for this thick client. So it's this could be expanded to lots of other examples as well. So if I had to give an example for this thing, imagine you've developed your own system, your own server, where you could compile your Python projects through your computer. You've made your own compiler. How have you done it? You've added a Raspberry Pi, you've added a setup. The Raspberry Pi does the processing, but it's not enough sometimes. So you've also added an old desktop computer that acts as a processing hub, or that gives processing power. So initially, although the network can be expanded, the initial cost will be higher. You need to invest in hard disks, you need to invest in Raspberry Pi, a computer, or different network architecture. So this is a con. So whenever you're talking about thin client and thick clients, it's important that you know the difference between them. If you know the difference between, you can justify the uses in each case. So I think the video has crossed the 13 minutes mark already. I will talk about cloud computing in our next video. Stay tuned, subscribe. Thank you so much.